Hello viewers, welcome back to our YouTube channel. Today we want to look at one of our last video in chapter 5, and as we said, we want to look at the Lorenz curve. In the previous video we looked at the O-give, and we want to finalize the presentation of data with a Lorenz curve. Lorenz curve or Lorenz curves. A Lorenz curve, of course, it is composed of a cumulative percentage frequency curve of the less than type. Of course, the Lorenz curve, this is a graph. This is a graph or a plot or graph that represents or plots that represents cumulative percentage frequency against the cumulative percentage class totals. Cumulative percentage class totals. The cumulative percentage totals. Cumulative percentage class totals. And of course, for a class total of any frequency distribution or of any frequency distribution class will be the total value of all items belonging to that class. So the class total will be of any frequency distribution class will be the total value of all items belonging to the class. So for us to be able to get the class totals, we get the class midpoint, then we multiply by the class frequency. Say that for us to get the class totals, will be equivalent to the class midpoint, then times the class frequency. That's how we will be able to get the class totals. Now once we get the class totals, of course, what we take to the other side, to the graph, will be now the cumulative percentage. So we get the class totals, we compute the percentage class totals, and then we compute the cumulative percentage class totals. So it's a very lengthy computation that we are going to go through in. So a Lorenz curve when we are looking at its steps, it has a horizontal scale. Its horizontal scale starts at 0%, that's the horizontal scale, and it ends at 100%. That is the horizontal scale. Horizontal scale, or the horizontal axis. The horizontal axis starts from 0% to 100%, because we said we plot cumulative percentage frequency against cumulative percentage class totals. So it means that even the vertical axis, will have the same thing. It will also span from 0% to 100%. Both the vertical and then the horizontal axes will have their figures starting from 0% to 100%, because we are plotting percentages against percentages. So what would be the purpose? The purpose of this curve is to demonstrate the relative proportions of values represented along the horizontal axis versus the values represented along the vertical axis. So we are just trying to find the relative proportion of the values that are being represented on both sides of the curve. Now, once you have drawn this curve, for you to be able to understand or to interpret it or analyze the details that it provides, it's better we draw what we call the equality curve. The equality curve. Equality curve. And this equality curve, it is just the line that we add to a Lorenz curve, so that we can be able to see the relationship, a one-to-one relationship. A one-to-one relationship. A one-to-one relationship. So this equality curve, or at sometimes they call it equality line. The equality line. Of course, this equality line shows how even or uneven a situation is. In other words, we try to look at, if it is a one-to-one, it means that it is even. But if it is maybe a 2-to-1, then this one is not even. So we want to look at the curve on both, because the Lorenz curve gives us the proportion. Now, when we are looking at these proportions, we want to make sure that the first proportion is equal to the second proportion. Or we want to determine whether the second proportion is bigger than the first proportion. And what is going to help us to get to that point is what we call the equality line. So it shows us the equal or unequal proportions or situations about whatever we are illustrating. Of course, it helps us to illustrate the distance between the two Pareto curves and the equality line. that line will be dissecting those two proportions. It will be the line that will be dividing the Lorenz curve into different proportions. So those proportions are going to tell us whether the situation is going to be equal depending on what we are illustrating, or it's not equal. So it is just an equality line. So we need to look at the steps, because I understand this, we will understand it more when we have done a practical simulation. So let's look at the steps for drawing a Lorenz curve. Steps to draw the Lorenz curve. Of course, the first step is to calculate. The first step is to calculate cumulative percentage frequency. Cumulative percentage frequency. Cumulative percentage frequency. Of course, you know that when you are computing the cumulative percentage frequency, you just cumulate the percentage frequency, the frequency percentages. The frequency percentages. In other words, we first draw the percentage frequencies or frequency percentages, then we cumulate them. We get their cumulative values. That's how we get the cumulative percentage frequency. So you first get your frequencies, then you get those frequencies, you get the total frequency, you get the individual frequency divided by the total frequency times 100. Then when we are done with that, you cumulate them in another table to give us the cumulative percentage frequency. And that's our first step. The second step is for us to calculate cumulative percentage class totals. In other words, we compute the percentage class totals and then we cumulate them. Of course, we are going to find ourselves giving the, if we are given the classes, we go ahead and we get the class totals if they were given to us. If they are not given to us, then we estimate them. We estimate our class totals using the formula that I told you, where we said we get the midpoint or the class mark, we multiply by the frequency. Then the third step is for us to, now we are going to plot. We plot the cumulative percentage frequency against, of course, this meaning this one are going to be on the x-axis, against the cumulative percentage class totals, and these are going to be on the x-axis or on the horizontal axis. So we plot these as set of points. And then, of course, the last step is for us to join the points and then we draw a straight line connecting those values. So once we are done with that, we said we join. This is step 4. Step 4, we join the points. We join the points, giving us the Lorenz curve, required. Now, once you are done with that, the last step is for us to draw the equality line of distribution. And of course, this equality line of distribution is always shown whenever we draw a Lorenz curve, because it's the one that is going to give us the economic variable. It's going to show us where the economic variable is shared, and we see whether it has been shared equally among the subject or the different variables that we are trying to plot. Of course, the key factor or the key thing that we need to look at as far as a Lorenz curve is concerned is basically its interpretation. The big question is, how do we interpret the interpretation of the Lorenz curve? Interpretation of the Lorenz curve. Of course, the aim of a Lorenz curve is just to show how the total value of the measurement of some economic variables are shared among the items that are involved. That is the basic fundamental aim. That we try to look at, are these resources, if they were resources, are these resources shared equally among the different participants? If they are not, it is just to tell us if they are equally shared or they are not equally shared. And that's why we put what you call the equality line. We do that equality line of distribution to see if indeed the variables under study are distributed equally, mainly from the economic point of view. So when you are comparing the Lorenz curve with the line of equal distribution, we try to look at the gap in between the line of the line of equal distribution and then the Lorenz curve. If we just look at the space in the middle from the curve to the line of equal distribution, is there the distance? You look at the space. If it is too wide, then it means they are less equally distributed. But if they are close, if the distance from the curve to the line of equal distribution is small, then it means they are evenly distributed. So we just look at how big are the sides after putting. That's why we draw a straight line. It's the line of equal distribution is just a straight line that pierces through the Lorenz curve. And of course, we look at both sides and we see whether the gap from because when you pierce the Lorenz curve, it is going to be divided into two portions. Those portions we just compare from the line to the curve. Is the distance big? If it is big, then they are less, or they are not equally, or they are less equally distributed. If it is very small, then we say they are equally distributed. So we basically look at the space in between the curve. If the space is too big, then we can say that it is not equally distributed. So the interpretation is basically to look at the space available between the line of equal distribution, they abbreviate it as red, and the Lorenz curve. So you just look at the space in between. If it is big, then they are not equally distributed. Of course, this curve is specifically used in some areas of its applicability is in those areas where we try to find the inequalities in connection to any given matter that we are trying to find out. Of course, it's going to be used in areas of, let's say, if you are looking at income inequality within the population. Maybe you are trying to study the incomes in the population. When you are studying the incomes in the population, you want to see whether there are so much deviation between those who have money and those who don't have money. So you try to look at the inequalities in connection to the matter that you are trying to study. That's why, that's basically where this Lorenz curve is basically applied in areas to do, if you want to look at the applicability, or where they are mostly used, is to show inequalities, let's say in areas to do with incomes in the population. It could be to show maybe tax payments of individuals in the population. We want to see, depending on the people that we have, who are those people that are paying more taxes and those that are paying less taxes. So we want to see the deviation. Is it true that those who earn more are taxed more? If not, so we try to look at the inequalities or the mismatches. We see how is it going to be evenly distributed among the people. If, let's say, you're looking at maybe examination marks to see those who have performed poorly and those that have performed well, to look at those maybe who have passed and those who have failed, to see the inequality, to see whether those who have failed are equal to those who have failed. So we try to use the Lorenz curve to basically get a picture of the distribution, how it's going to be spread away from the line of equality. You can look at even the industrial output, industrial efficiencies, whether people who are more skilled are going to be different from those that are unskilled, maybe according to their industrial produces. You can also look at maybe customers and sales. You look at the fact that if a company has very many customers, is it true that these customers will actually have more sales? Because it is very possible that you can have very many customers, but the sales are low. So the big question would be, are these customers buying enough to increase our sales, or they are just customers, but they buy their purchases are just small, and so they can't boost the sales? So those are some of the, if you are trying to get the inequalities in connection to any given matter, as we have spoke about, you use the Lorenz curve. So we don't want to make it more theoretical. Let's pick one question, then we see what we can do as far as the Lorenz curve is concerned. We want to pick one question, then we try to do some computations. So let's look at a simulation. Example, can say using the data of the table, below, estimate the total value of the repayments made by the members of each of the 9 classes, each of the 9 classes of the distribution, Then of course on this same question we have part A, we have both part A and part B. So this first one was telling us to estimate the total value of the repayments made by the members of each of the 9 classes of the distribution. So it means they have given us the repayments for different people, but they have grouped them into 9 classes. So we can have the table. We have the repayments. They are in thousands. And then we have the number of shop owners. They have displayed this as x less than 5. The second one is x is less than 13, is greater than or equal to 5 but less than 13. Then this one, the x here is greater than or equal to 13 but less than 17. So they are presenting them. These are exclusive classes. This one is 17. So this is 21. Let me give their classes. This one is 7. This one is 60. This one is 101. Then here we have a 21 less than or equal to x less than 25. So here it is 70. Then down here it's the 30. So move downwards. There are 9 classes, so we move and then we add these other ones. Then of course this one is 25 less or equal to x less or equal to 29. This one you can read it from this. You read it from the middle, that x is greater than or equal to 25 but less than or equal to 29. That's how we read it. Or you can read it 25 less or equal to x less or equal to less. This is 25 less or equal to x, then less 29, less than 29. So this is 29 less or equal to x less than 33. And finally we have 33 less or equal to x less than 37, meaning 37 is not inclusive in this last class. So here the frequency we have, this one is 10, next one is 8, and then lastly we have a 9. So the required part A, they are saying use this same data, use this same data to draw up, use that same data to draw up a table of cumulative percentage number of shop owners against cumulative percentage repayments. They want us to draw up a table of cumulative percentage number of shop owners against cumulative percentage repayments. Then part B, they want us to use this table to construct a Lorenz curve. So the first question, even if they had not asked us to get a table, there is no way we are going to be able to draw a Lorenz curve minus us first constructing the Lorenz frequency distribution, cumulative frequency distribution table for that Lorenz curve. So there are three questions that they asked us. The first one, they asked us to estimate the total value of the repayments made by the number of each of the 9. So my key concern is for this part A and part B, where they want us to draw a Lorenz curve. That's where my interest is. So let's organize our data set. Solution. Of course, these ones, they gave us the repayments. They are in thousands. But I can organize them from maybe 0. This one you can say less than 5. Or you can start with a 0. Let me show you how we can change this. We can say 0 to, we put it, we remove those less than or equal to, those inequality signs. But of course, if you are answering the question, you may maintain them the way they have given them to you. It has no problem. But to just make our work neat, we are going to organize it a little bit, because we have known that this is actually this is an exclusive class, whereby the 5 is not included in the first class. So this one we can say 0 to 5, then 5 to 9, then 9 to 13, 13 to 17, 17 to 21, then 21 to 25, and then 25 to 29. Then we put our middle point. Let's first maybe finish all of it, because there were 9 classes that they gave to us. So we need to make sure that all the 9 classes are included. So we show all our 9 classes, and of course the other one is 29 to 33, and then 33 to 37. So let's start by getting our midpoints. And we know that for us to get that x, or our midpoint here, we get, for us to be able to get our midpoints here, we add this plus this, we divide by 2. So it is 0 plus 5 divided by 2, that will give you a 2.5. 5 plus 9 divided by 2, this will give you a 7. And then 9 plus 13 divided by 2, it's 11. This will be 15. This will be 19. This will be 23. Of course, we look at others down. Even that one, you can check the class interval, and then you'll be adding the class interval to the number above. You'll still get the same answer. This is 25 plus 29 divided by 2. It gives you 27. Then this is 31 and 35. Those are our midpoints. Now we go and calculate we provide the frequencies. The frequencies were given to us. Frequencies were given to us. I'm going to name these frequencies as F. Let me use letter F to represent the frequencies. The frequencies that was given to us for the first one, this was a 7. This is 60. This is 101. This is 105. This is 70. 30. So include all these others. So the one that was given to us here is a 10. This one is 8. This is 9. So those ones we are done. What we are going to compute are what we call the class totals. And we say the class totals are actually midpoints. Midpoints times the frequency. Times the frequency. So it is x times f. It is x times f. So that's what we are going to get next. So we are going to call it letter V, just to show that we are multiplying frequency times the midpoint. So we are getting the f times x, fx. So we are multiplying this times this. We get what you get will be letter V. Let me call it letter V to show that that is the value, the class value. So it is 7 times 2.5. It gives us a 17.5. So this is 17.5. Then we go to 7 times 60. It gives you 420. 11 times 101. It gives you 111. 15 times 105. It gives you 1575. That is 1575. So we move along to get the other values. So we fill in these values as well. 19 times 70, that gives you 1330, that is 1330. 23 times 30, it gives you 690. 27 times 10, that is 270. Then this will be 248, and lastly it is 315. Those are the values for, those are the class totals. But now we need to get the cumulative frequency. We also get the, what is left for us to do is to get now the, first the cumulative frequency. When we get the cumulative frequency, then we shall get the cumulative values, cumulative of these values that we have gotten here, cumulative of this and even cumulative of this side. And after that, then we compute the percentage. So we can get the total value here. To make it simple, because we need the percentage, we need the cumulative percentage totals. So let's first compute the percentages so that we can, let's get the total for that one at once. Let's get the totals here. We get the summation fx. Once you add all those values, you will get 5976.5. 5976.5, that is the total there. Of course, if you want, you can also compute the totals for the frequencies, these ones here. If you want, you can also get the summation f. Of course, this is 400, but even if this one you don't get it, because the moment we get the cumulative frequency, we shall get the total. But you can compute it as well if you want to have it there. So of course, what we are going to do is to make sure that we get now the percentage of each of those values. For the values, we get the percentages. I've got those values, but we are going to prove them. We are going to prove those values. So let's first get the cumulative frequency first. Cumulative frequency. I'm going to call it CF, cumulative frequency. For this, the cumulative, when you are accumulating values, you maintain the first value. It's like getting 0 plus 7, that will be 7. So here is 7. So 7 plus 60, it becomes 67. 67, then 67 plus 101, it becomes 168. 168 plus 105, it becomes 273. 273 plus 70, this plus this, it gives you 343. Then 343 plus 10, it gives you 373. Then you add 8, it will give you 391. Of course, we are moving down. So we are going to find that the total we are going to have here will be this. 400 will be this one. So once we add, we said it is going to, when we add the 10, it is going to give us 383. Then plus the 9, It is 391 plus the 9. The other one was plus 8. This one gives you 391, then plus 9, it gives you 400. That's where you confirm that this is actually the same value that we have here. The total, because we are just adding to get the entire totals for the frequency. Then we do the same thing for the values. We do the same thing for the values, which is the FX30V. We can just get the, of course, you can first get the percentage, then you accumulate them, but that will create very many columns. So it is better we get the cumulative, then we shall get the cumulative. We shall now compute the percentages from the cumulative values. But either way you choose to go will be right. You can first of all get these values. You get 17.5 divided by the other total. The total was 5976.5. 17.5 divided by 5976.5. The answer you get, multiply by 100 because you are computing percentages, and you will get 0.29292. You can round that off to be a 0.3, but that will create very many columns which are not necessary as per the exam, because you will be saving time. So what you do, you make sure that you come and indicate, now I'm going to get the cumulative. Let's first get the cumulative of V, CV, let me call it CV, but we are getting the cumulative value for this. Can first get the cumulative value for that, then after that we compute now when you have gotten the cumulative value for that one, then we compute the percentage now of V, which will be the percentage of CV, the cumulative percentage for V. Then we do the same thing for the cumulative frequency. Maybe the cumulative frequency here, we can call it F. Then we get the percentage of F. When you get the percentage of F, of course, we are going to be plotting these last columns. These last two columns, they are the ones that we are going to be. So what you do, you get this. It is this one. We add a 0. It will be the cumulative here, 17.5. So we cumulate this. 17.5 plus 420, it gives you 437.5. This plus this, 111, it gives you, this one will give you 548.5. 548.5. Then some of this we added them wrongly. So there is a 0.5, you don't, because if you get to sum them up, they are going to confuse you. So it is 548 plus the 1575. That will give you, plus the 548.5, it gives you 2123.5. 2123.5. Let me create a bigger space. This is 2123.5. Then we add the 1330, it will give us 3453.5. So we finalize this and we add the 660 plus the 3453.5, and it will give you 441.43.5, then plus 270, it gives you 4413.5, 4413.5, then plus 248, that gives you a 466.1.5, then plus the 315, that gives you a 4976.5. So these values here, we need to double check our arithmetics to see whether, because the total is supposed to be this 4976. That's the total we've gotten. So you double check our computation so that we don't make errors. On this one, we made some arithmetic errors here. When we are multiplying this 11 times 100 and 101, it was supposed to be quadro 1. So we would have 11, 11, 11. So here, so you will see that where we got it wrong here, 11 times this. That's why we are getting these values. These values are not right. So you make sure you write these values well. Otherwise, this total is actually 1158, because you can see that we missed it by just 1000. This value here, it means we excluded 1000 and we only took that. That's why we are seeing this value we have here is less by 1000 here. The difference in the values that we have here, the difference in values that we have here and what we have here, the difference is just 1000, and that 1000 got lost from the other when we are multiplying 11 times 101. So meaning this side we must have this same total. That's why I first gotten these values to make sure that what we have here is the same as what we have here. So the right value is supposed to be this one, because this value was inclusive of this 1000 that we had skipped. So you can adjust that as we move on. Let me adjust with the right values. So this one is supposed to be 1548.5. This one is 3123.5. This is 4453.5, and this is 51443.5. This is 5413.5, and this is 5. So this one is 5 661.5, and then lastly is 5975.5. So we have gotten the summation fx, the value which is this 5975.5. So what we are going to do is we are going to get the percentage. So since this is our cumulative value, we just now compute the percentages. So we just get each of these individual values. We just get, like, for this one, we get this divided by this times 100. That's what we write for the value, the percentage value. Then for the percentage frequency, we get this cumulative frequency, this one divided by this, because this is the total frequency times 100, and that will give us the answer. Of course, the one for this last one will be 400 over 400 times 100. That will give you 100. So that's just one way of saving. Otherwise, someone would get this over the total times 100. Then you put it there. After that, you compute the cumulative value, but that will call for a lot of time. So let's compute these values. We get the cumulative value, but in percentage. So we just get this divided by the other total. This will be 1.8. Of course, it will be 1.75, but we round off, we get 1.8. This is 27. Now this will be, the second one will be 27. Then this one will be 42. Then 68. Then 86. 93. Then for this is for cumulative. This is the cumulative frequency percentage. Then for the percentage value, percentage V, this one you can also compute it at once. It will be this divided by the other total of 5976.5 times 100. This will be 0.3. Then the next one will be a 7. The next one is a 26, 52, then 75, 86. Then let's finalize these other ones. Of course, we are going to draw the graph using these two columns, this one and this one. You put the percentage. They have told us what to put. They told us to draw a table of cumulative percentage frequency of number of shop against number of shop owners against the cumulative percentage repayments. So this one is 100%, and also this one is 100%. That's why we told you that these are actually going to be, they are going to be starting from 0 and they are ending at 100%, both of them. So you go ahead now, you get the scale. Of course, you know it is going to be 100% on both sides. Then you draw the graph. So you draw the graph. You put, they are all supposed to be at 100, even this one at 100. Suppose maybe 20, 50. Can say this is 20, maybe 50, 60, maybe 100. Then you start plotting. Of course, you will see it starts from 0. So you will see that if you get the good scale, you'll find that we are going to be plotting values. The curve may look like this. Now, how do we draw the line? The line, we draw it from this last point here, and then this last point. You connect, you draw a straight line connecting these two values. To make an interpretation, you look at the gap here. If it is big, then you conclude. So that's how basically we draw the Lorenz curve.